Hello everyone. Today I'm going to start linear algebra. Here we are going to learn that in this chapter we shall discuss the matrix algebra and its use in solving the linear system of algebraic equations such that Ax is equals to B, and in solving we use the eigenvalue problems, that is Ax is equals to lambda x. Now, here comes the definition of matrices. A system of m cross n numbers arranged in the form of the rectangular array having m rows and n columns is called a matrix of order m cross n. Suppose that a matrix A is equals to A of ij, that is of order m cross n, and B any matrix of order m cross n, then it can be written in the form of horizontal rows and columns. Some special types of matrices: square matrix, an m cross n matrix for which m is equals to n is called the square matrix. It is also called an n-row square matrix. The element A of ij are called the diagonal element, and the line along which they lie are called the principal diagonal of the matrix. Element other than etc. are called the off diagonal elements. Diagonal matrices: a square matrix in which uh, all of diagonal elements are zero is called a diagonal matrices, and the diagonal element may or may not be zero. If a diagonal element are such that A of ij is equals to zero, in there is a case if I is equals to j, I is equals to j, and A of ij when I is equals to j. Properties of the diagonal matrix are diagonal matrix of x, y, z and diagonal matrix of PQR. When we add those diagonal matrices, then the diagonal matrix will form, that is of x plus p and y plus q and z plus r. Diagonal of x, y, z into diagonal of PQR is equals to diagonal of xp into yq into zr. Diagonal of x, y, z matrix to the power minus 1 is equals to diagonal of 1 by x, 1 by y, and 1 by z. Diagonal of x, y, z transpose is equals to diagonal of x, y, z. Diagonal of x, y, z to the power n, that is equals to diagonal of x की power n, y की power n, and z की power n. Eigenvalues of diagonal x, y, z are x, y, and z, and determinant of the diagonal of x, y, z, that will only be the x, y, and z. Scalar matrix. A scalar matrix is a diagonal matrix with all the diagonal elements being equal. That is, Aij is equals to 0 if I is not equal to j, and Aij is equals to some constant, that if I is equals to j. Unit matrix or identity matrix. A square matrix with each of those diagonal element is 1 and each of whose non-diagonal element are 0 is called a unit matrix or an identity matrix, which is denoted by I. Identity matrix is always square. Properties of the identity matrix. That I is an identity element for multiplication, so it is called the multiplicative identity. AI is equals to I into A, that will always be equal to the original matrix. I, that is an identity matrix to the power n, will always be equal to the identity matrix. Identity matrix to the power minus 1 will always be equal to the identity matrix. Determinant of any identity matrix will always give the 1. Null matrix. The M cross n matrix whose elements are all 0 is called the null matrix. Null matrix is denoted by 0. Matrix need not be square, that is A of ij is equals to 0 for all I and j. Properties of null matrix, that is A plus O is equals to O plus A, that is always be the that A matrix. Upper triangular matrix. So an upper triangular matrix is a square matrix whose lower off diagonal element are 0. That is A of I is equals to 0 whenever I is greater than say, and it is denoted by U. The diagonal and the upper off diagonal element may or may not be 0 if and only case A of ij is equals to 0 when I is greater than j, and A of ij will be some constant if I is less than j. Lower triangular matrix. A lower triangular matrix is a square matrix whose upper of diagonal triangular element are 0. That is, A of ij is equals to 0 whenever I is less than j. The diagonal and the lower of diagonal element may or may not be 0 if and only if A of ij is equals to 0 if I is less than j. It is denoted by L. L matrix is a lower triangular matrix. That is upper half of the element of the leading diagonal having the zero elements. Idempotent matrix. A matrix is called the idempotent if original matrix square is equals to that matrix only. That is, A square is equals to A. Involuntary matrix. A matrix is called the involuntary matrix if matrix original matrix square is equals to the identity matrix. Nilpotent matrix. A matrix A is said to be a nilpotent of class X or the index X if and only if the matrix A raised to the power X is equals to null matrix, or the matrix A raised to the power X minus 1 is not equal to the null matrix. That is, X is the smallest index which makes A to the power X is equals to null matrix. Singular matrix. If the determinant of the matrix is 0, then the matrix is called as a singular matrix. That is, determinant will always be 0. So if the determinant is not 0, then matrix is known as a non-singular matrix. And if matrix is singular, then its inverse doesn't exist. Row matrix. A matrix with only one row is called as row matrix. A row matrix can have any number of columns, that is, it has the order of 1 cross n, where n belongs to the natural number. Column matrix. A matrix with only one column is called as a column matrix. A column matrix can have any number of rows, that is, it has an order of m cross 1, where m belongs to the natural number. Equality of two matrices. Two matrices such that A is equals to A of ij element and B is equals to B of ij element are said to be equal if and only if they are same size and the element in the corresponding places of the two matrices are the same. That is, A of ij is equals to B of ij for each pair of the subscripts I and j. That's all for today. Thank you.